In this lesson, we'll be implementing routes that are essential to our authentication workflows, being sign in, which will authenticate a user by verifying their credentials, such as username, password, or an identity token from an identity provider, and manage authenticated state by issuing a portable token, such as a JWT. And lastly, sign up, that will let users register into our system. Alright, so let's switch to our IDE and start setting everything up. Let's start off by generating a new authentication controller in our existing IAM module using the Nest.js CLI, with nestgcontroller IAM/authentication. Note we're generating this controller in the new dedicated authentication folder just so we can have a clear separation between the authentication and authorization related files that we'll be working on in future lessons. We will also need an authentication service, so let's generate that as well, via nestgservice IAM/authentication. Great. Before we start adding methods to our authentication service and implementing the sign-in and sign-up functionalities, let's generate the DTO or data transfer object classes for two endpoints we plan on exposing in our application, being sign-in DTO and sign-up DTO. Next, we're going to install two packages that we'll be using to validate any incoming requests. You may remember these from the fundamental course as they're an essential part of almost every Nest.js application. Let's enter in npmi class-validator and secondly class-transformer. We'll be continuing ahead as we already have these installed, but if you're planning on following along, just pause the video and come back when everything's finished. Now with everything installed, let's open up our main TS file and add the following line. app.useGlobalPipes, and let's pass in new validation pipe, making sure to import it from nestjs/common. With our validation pipe in place, we can move on to our DTO classes now. Let's start with the sign-up endpoint that will let users register into the system. To register a new user, we'll need credentials. Let's add email and password properties into our sign-up DTO class. Next, let's apply some validation annotations, like isEmail for the email property, which will validate if the specified email is in fact an email. And for the password property, let's add min-length 10, as we don't want to accept passwords that are less than 10 characters long. Alright, with our validations in place, we can now switch to our authentication service. In order to create new users, this service will need to use the user repository. So let's inject it into our constructor using the inject repository decorator. Note that before we insert a new user row, we have to make sure to hash the passwords we receive. To achieve this, let's inject the hashing service we created in the previous lesson. With these dependencies injected, we can now declare a new signup method in our class. This method will take the signup DTO instance as an input argument. Inside of this method, we can start by creating a new user entity instance like so. Since we flagged the email column as unique, Postgres may throw the unique violation constraint error just in case there's another user already registered in our users table. Let's make sure to wrap this code into a try-catch block to handle this exact scenario. Note, as a best practice, ideally, we should have declared the PG unique violation error code constant in a dedicated file, so it can be reused elsewhere in our codebase. But just to keep things in this lesson simple, we'll leave it as it is for right now. With signup wrapped up, let's move on to the sign-in side of things. First, let's open up the sign-in DTO class and add some missing properties. To sign in, a user will have to provide us with an email address and their valid password. Let's also apply the same set of validation constraints we did in our signup DTO class. With our class updated, let's switch back to the authentication service again and define another method right below the signup and name it sign-in or login if you prefer. This method will take just one argument, sign-in DTO, which is our credentials object containing the email and password that the user will send over the network. Inside of this method, let's add the following code and break it down line by line. First, we have to check to see if a user with the given email address exists in our system. Afterwards, we can use the hashing service to check if the provided password matches the hashed version that we stored in our database. If any of these two operations fail, we throw an unauthorized exception, otherwise we return true as they've been properly authenticated. Note that in the next lesson, we'll be improving this even further by returning a JWT access token instead of returning a Boolean value. Okay, so with the corresponding service methods in place, let's switch over to the authentication controller class and inject our service there with the standard dependency injection approach. Inside our controller, let's define two methods. One for the signup route, and another for the sign-in route. The sign-in route will have one subtle difference. In this method, we want to use the HTTP code annotation to instruct the Nest framework that in case of a successful operation, we want the HTTP status to be 200 instead of 201, which is the default for post routes in Nest. Lastly, let's open up our IAM module and first create an imports array inside of the module decorator. In this imports array, let's add typorm.forFeature passing an array with our user entity inside of it. And just like that, we made the user repository available to our authentication service. Now that we have this in place, we can switch to Insomnia and test out these endpoints. First, let's try to sign in using invalid credentials, which right now will always be the case as we haven't created any users yet. As we can see, we received the 401 response that says unauthorized, which is exactly what we should expect. Now let's call the signup endpoint passing in the exact same user body and create a user in our database. As we can see, we received the 201 status code back, which means that the user was successfully created in our database. Great. Just to make sure our conflict detection mechanism works as we intended, let's call this API again, passing in this same set of credentials. Excellent, it works. We received the conflict error message back. As we know, this helps prevent us from having duplicate users in our database. One last thing, let's switch back to the sign-in route and call it passing credentials of the user we just created. And as we can see, it works now. Since the user is now within our database and we're passing in the correct password, we're now able to sign in successfully. Let's try calling this API again, but this time with an incorrect password. Excellent. We received the 401 unauthorized just as we should. Although the response schemas of our endpoints are not ideal yet, we have the authentication part working well so far, but we're far from done. We'll keep on improving everything more and more in the upcoming lessons.